What would actually happen if the Earth suddenly stopped spinning? At first, it sounds like a simple idea. The planet just stops. But in reality, almost everything around you is already moving at incredible speed, and that's where the real problem begins. Right now, the Earth is rotating at roughly 1,670 kilometers per hour at the equator. You don't feel it because everything around you is moving at the same speed. The ground, the air, the oceans, all of it is synchronized. If the Earth stopped spinning instantly, you wouldn't just stand still. Everything that is not firmly attached to the ground would continue moving at that speed. That includes you. Buildings, cars, trees, and even the atmosphere would be violently thrown eastward at hundreds of meters per second. The result wouldn't feel like a strong wind. It would be more like being hit by a planetary-scale shockwave. Entire cities would be wiped out within seconds. Anything not anchored deep into the ground would be dragged across the surface. The destruction would be immediate and global. But even that is just the beginning. The atmosphere itself is also moving with the Earth's rotation. If the surface suddenly stopped, the air would keep moving, creating winds far beyond anything we experience on Earth. Not storms, not hurricanes. Something much more extreme. Winds could exceed 1,000 kilometers per hour, circling the planet and stripping away everything on the surface. Dust, debris, water, all of it would be lifted and carried across continents. Breathing would become impossible in many regions. Now consider the oceans. Water has inertia, just like everything else. If the Earth stopped, the oceans would not. Massive volumes of water would surge across the land, creating megatsunamis that would travel thousands of kilometers. Entire coastlines would disappear. Low-lying regions would be flooded almost instantly, while other areas would be left dry as water redistributes across the planet. But there's a deeper effect that's less obvious. The shape of the Earth itself would begin to change. Because the planet is spinning, it isn't a perfect sphere. It bulges slightly at the equator due to centrifugal force. If rotation stopped, that force would disappear. Over time, gravity would pull the mass of the planet into a more perfect sphere. This means that water currently concentrated around the equator would begin to move toward the poles. In the long term, vast regions near the equator could become dry land, while areas closer to the poles might be submerged under deep oceans. Entire continents would slowly reshape. But let's go back to something more immediate: gravity. Stopping the Earth's rotation would not change gravity itself. You wouldn't suddenly float away or become weightless. Gravity is determined by the planet's mass, not its rotation. However, you would feel slightly heavier. Right now, the rotation of the Earth creates a small outward force that slightly counteracts gravity, especially near the equator. Without rotation, that effect disappears. The difference wouldn't be dramatic, but it would be noticeable. Now think about day and night. Without rotation, the concept of a 24-hour day disappears completely. Instead of the sun rising and setting, one side of the Earth would face the sun continuously, while the other side would remain in permanent darkness. One half of the planet would experience constant daylight, the other half endless night. On the day side, temperatures would rise dramatically. Without the cooling cycle of night, the surface would heat up continuously, especially in regions directly facing the sun. Deserts would expand. Water would evaporate faster. In extreme cases, parts of the surface could become nearly uninhabitable due to heat. On the night side, the opposite happens. Without sunlight, temperatures would drop continuously. Over time, large areas could freeze, turning into vast, frozen landscapes. The difference between the two sides of the planet would become extreme. Between them, there might exist a narrow zone, a kind of permanent twilight where conditions are more stable. This region could become the most habitable area on Earth. But even that environment would be unstable due to constant atmospheric movement between the hot and cold sides. Now consider the impact on life. Most ecosystems on Earth depend on the cycle of day and night. Plants rely on sunlight, but they also rely on periods of darkness. Animals have biological rhythms tied to this cycle. Without rotation, these natural rhythms would collapse. Agriculture would become extremely difficult. Many species would not survive the sudden environmental changes. Human civilization, as it exists today, would not be able to function under these conditions. But there's an even more fundamental question. Could the Earth actually stop spinning? In reality, something powerful enough to stop the rotation of an entire planet would release unimaginable amounts of energy. The event itself would likely be far more destructive than any of the consequences we've described. So while the idea of the Earth suddenly stopping is useful for understanding how our planet works, it's not something that could realistically happen without catastrophic external forces. Still, it reveals something important. We live on a planet that is constantly in motion, even though it feels completely still. Every second, we are spinning through space, orbiting the sun, and moving through the galaxy, all without noticing. And everything we experience, day, night, weather, even the shape of our world, depends on that motion continuing exactly as it is. If it stopped, even for a moment, the world would become unrecognizable. And life, as we know it, would change completely. But even after the initial destruction, the most dramatic changes would still be unfolding. Once the atmosphere begins to redistribute itself, the entire climate system of the planet would break down and rebuild in a completely new form. On a rotating Earth, winds are shaped by the Coriolis effect, which causes air to curve as it moves. This is why weather systems spin and why global wind patterns are relatively stable. If the Earth stopped rotating, that effect would disappear entirely. Air would no longer move in curved paths. Instead, it would flow directly from areas of high pressure to low pressure in straight, massive currents. The result would be a constant exchange between the hot side of the planet and the cold side. Hot air from the day side would rise and move toward the night side, where it would cool, sink, and return again. This would create enormous, continuous wind systems spanning the entire planet. These winds would not settle into calm patterns. They would remain strong, persistent, and difficult to predict. Storms, as we understand them, would change completely. Instead of rotating hurricanes or cyclones, the planet would experience vast, migrating atmospheric flows that could last for months or even years without stopping. Now think about water again, but this time over longer periods. As temperatures rise on the day side, evaporation would accelerate. Large portions of the oceans facing the sun would gradually lose water to the atmosphere. That moisture would then be transported toward the colder regions. On the night side, where temperatures remain low, this moisture would condense and fall as snow or ice. Over time, massive would begin to form. Entire oceans could slowly migrate from one side of the planet to the other, evaporating in one region and freezing in another. This would create a planet where water is no longer evenly distributed. Instead, you would have extreme imbalance, hot, dry regions on one side and cold, ice-dominated landscapes on the other. The boundary between them, the twilight zone, would become a place of constant change. Fog, storms, shifting winds, and unstable temperatures would define this region. It might be the most survivable area, but it would also be one of the most unpredictable. Now consider the magnetic field. Earth's magnetic field is generated by the motion of molten material in its outer core. While the planet's rotation contributes to this process, it is not the only factor. However, a complete stop in rotation could disrupt the internal dynamics of the planet. Over long time scales, this might weaken the magnetic field. If that happened, Earth would become more exposed to solar radiation. Charged particles from the sun would interact more directly with the atmosphere, potentially stripping away lighter elements over time and increasing radiation levels at the surface. This would make survival even more difficult, especially without modern technology. Now imagine how human life would adapt, if it could at all. The first challenge would be location. Living on the permanently lit side would mean dealing with constant heat and radiation from the sun. Energy might be abundant, but so would extreme temperatures. Living on the dark side would mean permanent cold, limited solar energy, and frozen environments. So most human settlements would likely concentrate near the boundary zone. Cities would have to be built with protection from constant winds and shifting weather. Agriculture would need to adapt to low-angle sunlight or artificial lighting. Food production would become a controlled process rather than something dependent on natural cycles. Energy systems would also change. Solar power would be extremely effective on the day side, but nearly useless on the night side. Wind energy, however, could become one of the most reliable sources given the constant atmospheric movement. But infrastructure would need to withstand continuous stress from strong winds and temperature differences. Transportation would also be affected. Without a rotating frame of reference, navigation systems based on current models would need to be completely redesigned. Air travel, in particular, would become more dangerous due to unpredictable global wind patterns. Even communication systems might need adjustments due to changes in atmospheric structure. Now consider something more subtle: time. Without a day-night cycle, the way humans perceive time would change. The 24-hour system is deeply tied to the rotation of the Earth. Without it, societies would need to define time artificially. Work, sleep, and activity would no longer be synchronized with natural light cycles. This might not sound critical, but biological rhythms, known as circadian rhythms, are deeply connected to light and darkness. Disrupting them has significant effects on health. People would need to rely on controlled environments to maintain stable daily routines. Artificial lighting would become essential not just for visibility, but for regulating human biology. Now zoom out even further. A non-rotating Earth would not just feel different. It would function as a fundamentally different planet. Its climate system, water distribution, atmospheric behavior, and ecosystems would all operate under new rules. It would still orbit the sun, gravity would still hold it together. But almost everything else would change. And perhaps the most important realization is this: the stability we experience on Earth is not accidental. It depends on a precise balance of motion, energy, and physical laws. Rotation is not just a detail. It is one of the key factors that makes our planet habitable. Without it, Earth would still exist, but it would no longer be the world we recognize. And everything that depends on that balance, including life as we know it, would have to adapt or disappear. But there is another important layer to this scenario that is often overlooked. Even if we imagine that life somehow survives the initial shock, the long-term geological processes of the planet would also begin to change. Earth's rotation plays a role in how mass is distributed across the planet. When rotation stops, the redistribution of water and land is only part of the story. the internal structure of the planet would slowly respond as well. Over time, tectonic activity could shift. The balance between the crust, mantle, and core is influenced by many factors, and rotation contributes to how energy is transferred within the planet. Without it, the long-term behavior of tectonic plates might change in ways we don't fully understand. Earthquakes and volcanic activity could become more unpredictable during the transition period. Now think about satellites. Everything currently orbiting Earth, communication satellites, GPS systems, weather monitoring networks, is designed with Earth's rotation in mind. If the planet suddenly stopped, the reference frame would change instantly. Satellites would still be in orbit, but their relative motion to the surface would be completely different. Some would no longer pass over the same regions. Others might require constant adjustment to remain useful. Global communication systems would be disrupted. Navigation systems that rely on precise timing and positioning would become unreliable until recalibrated. In the short term, this would create chaos in transportation, logistics, and global coordination. Now consider something even more subtle: the sky itself. Without rotation, the stars would no longer appear to move across the sky in the way we are used to. Instead of rising in the east and setting in the west, the stars would remain almost fixed in position, slowly shifting only due to Earth's orbit around the Sun. On the day side, the Sun would remain nearly stationary in the sky, depending on your location. Near the point directly facing the Sun, it would appear almost frozen overhead. Farther away from that point, it would sit low on the horizon, never rising or setting. On the night side, the sky would be permanently filled with stars. No sunrise, no sunset, just a constant, unchanging view of deep space. For humans, this would be psychologically significant. Our perception of time, direction, and daily life is deeply connected to the movement of the sky. Removing that motion would change how we experience reality itself. Now let's return to the idea of survival, but in more practical terms. If humans were to adapt, they would need to create controlled environments. Cities would likely become enclosed or semi-enclosed systems, protecting inhabitants from extreme winds, temperature differences, and radiation. Food production would move indoors, relying on artificial lighting and carefully managed conditions. Water would need to be transported or recycled, especially in regions where natural sources have disappeared or frozen. In many ways, life would become more artificial. Instead of adapting to the planet, humans would need to engineer stable environments within an unstable world. This would require enormous amounts of energy and resources. Only highly advanced and coordinated societies could maintain such systems. Now consider ecosystems. Plants, animals, and microorganisms have evolved under very specific conditions. Temperature cycles, sunlight exposure, seasonal changes, all of these shape how life behaves. If those patterns disappear, many species would not be able to adapt quickly enough. Mass extinction events could occur. Only the most adaptable organisms, or those protected by human systems, might survive. Over long periods, new ecosystems could emerge, but they would be very different from what exists today. Life would reorganize itself around the new conditions. Now think about the long-term balance of the planet. Even without rotation, Earth would still orbit the Sun. This means that over the course of a year, different regions of the planet would receive varying amounts of sunlight depending on axial tilt. However, without daily rotation, these changes would be slow and uneven. Seasons would still exist, but their effects would be amplified in extreme ways. Regions on the edge between light and dark might experience gradual shifts in temperature over long periods, rather than daily cycles. This would add another layer of instability to an already extreme environment. Now step back and consider the full picture. The Earth would no longer be a dynamic, balanced system with cycles that support life across the entire planet. Instead, it would become a world of extremes. Permanent heat on one side, permanent cold on the other, violent atmospheric flows connecting them, oceans redistributed, land reshaped, ecosystems collapsing and reforming, human life forced into controlled, artificial environments. And all of this from a single change, the loss of rotation. It highlights something that is easy to ignore in everyday life. The conditions that make Earth stable and habitable are not simple or guaranteed. They depend on multiple systems working together in precise ways. Rotation is one of those systems. It regulates temperature, drives weather, shapes oceans, and supports biological rhythms. Without it, the balance breaks. And once that balance is gone, the planet does not gently adjust. It transforms. Not instantly into something unrecognizable, but steadily, forcefully, and irreversibly. So while the idea of Earth stopping might seem abstract, it reveals something very real. The world we live in is defined by motion. And that motion is not optional. It is fundamental. Remove it, and everything else begins to change.